Hi friends, welcome to the class of data warehousing and data mining. In this lecture we will see what is this association rule mining. So the main aim of this association rule mining is to generate what are strong association rules and what are weak association rules from the rules that can be generated by given database. So we will see that one how to do this association rule mining. So this can be viewed as a two-step process. In the first step, we need to find all frequent item sets. In the second step, generate strong association rules from the frequent item set. The first step is to find all frequent item set. How to find all frequent item sets? Again, two methods are there. One is a priori method, other one is FP growth method. You can choose any one. So after that, you will find all frequent item sets from the Apriori method or FP growth method. After that, we'll get all frequent item sets from any one of these methods if you use. And after that, by taking those frequent item sets, we can generate strong association rules from the frequent item sets. How to do that one? Where the strong association rules are which must satisfy minimum support and minimum confidence. Anyway, we'll see this one also. First, we'll go for finding all frequent item sets. After that, we'll come to this part, that is generating strong association rules. So first we'll do this finding of frequent item sets with a priori method. Then we'll come to this generating of a strong association rules. Now we'll go for the a priori algorithm. So instead of going first to this theory part, I'll explain this a priori algorithm with an example. After that, we'll come here and we'll understand what is this all those things. But remember, this a priori property, that is all non-empty subsets of a frequent item set must also be frequent, and especially we'll have again two steps, that is join step and prune step. We'll have join step and prune step. Remember this point. So let us consider one database here which consisting 9 transactions, where in each transactions what are the list of items that are purchased by customer. So in the first transaction 3 items are purchased, that is I1, I2, I5. In the second I2, I4, like this you have all the transactions. Now the question is asked like find all the frequent item sets by using Apriori algorithm, where the minimum support is given as 2, that is minimum support count is given as 2. So how to process this and how we can find the frequent item sets here. So we'll see this. What is our first step? So here you can see scan the D means database, scan the database for count of each candidate in the sense each product. Here you can see, so how many products are there? Totally 5 products, I1, I2, I3, I4, I5. So scan the database, that means you need to find count of each items. That means that count we call it as support count. So for I1, how many transactions consisting of I1, you can check it. The total count is 1 2 3 4 5 6. I1 count is 6, like this we can write. What about I2? So how many transactions consisting I2? So 7, like this. I3 6, I4 2, I5 again 2, like this you need to write, and this we call it as C suffix 1. Now the next step is compare candidate support count with minimum support count. What is the minimum support count is given 2. So compare it, that means compare in this support count. Of course here we call this C1 as also one frequent item set. We call it as one frequent. Why we call it as one frequent means in each record, in each line you can see only one item is there. That's why this is one frequent. Anyway, in the next we'll find 2 frequent, after that 3 frequent, like that. After finding support count in one frequent item sets, now you need to compare with the minimum support count, that is 2. So how many items are satisfying this minimum support count? If you observe, all the items are satisfying the minimum support count. So at least 2 should be the support count. So all are satisfying, no? Write all those things. Whatever the item sets are satisfying, that you need to write here. So now this will become L suffix 1. You have taken C1, then you are getting L1 from C1. After that you need to find C2 from L1. After that you need to find L2, like this. After that you need to find C3 from L2, like this. So up to, if you find the total records are empty, you need to do like this. So now after L1 you need to find C2. What is C2 actually? So C1 means one frequent item set. C2 means you need to generate 2 frequent item set. you need to generate two frequent item set. So what is this two frequent means? From L1 you need to make joins of two frequent. Joins in the sense I'll make one join, that is I1 I2, another join I1 I3, like this. So I'm writing here I1 I2 is the one join, I1 I3, next I1 I4, I1 I5. From I2 I1 can I write? See, I2 I1 is also equals to I1 I2, so I cannot write I2 I1. Next I2 I3 I can write, next I2 I4 I can write, next I2 I5 I can write. So next, what about I3 I1? I1 I3 is there, so I3 I2, I2 I3 is there, so I can write I3 I4, I3 I5. So final one I4 I5. So like this I need to generate these things. You call them as two frequent item sets. All these things are, you call them as two frequent item sets. So now you need to write these two frequent item sets. You call it as C2. Here you can observe, this is this part you can observe. C2 means all the two frequent item sets I am writing here, two frequent item sets. Now after getting two frequent item sets, and find again the same thing, that is to scan the database count of each candidate. After finding this for C2, support count you need to write. What is the support count? Where the count should be taken for each item set. That means how many transactions consisting of I1 as well as I2. Let me take this example here. So I1 I2 I have written. So how many transactions consisting both I1 I2? This is the one transaction, second, and here I1 is there, no I2. Here also no I2, I cannot consider. Here I1 I2, third transaction, here 4. So totally I1 I2 the support count will be 4. What about I1 I3? So I1 and I3, 1 2, I1 and I3, I1 and I3, 4. So irrespective of whether other transactions, other items are there or not, we cannot check that one. Now I1 I4. So I1 I4, I1 and I4, this is a one transaction, only one transaction. Next I1 I5, I1 2, only two transactions. See, like this we need to consider. If I write all those things like this, I'll get the theme as like this. So here the support count for all those things. So this is, we call it as C2. See, from L1 we are getting C2, which is a two frequent item set. Now we need to go for L2. What is L2? Again comparing the candidate support. What is our minimum support constraint? It is 2. So minimum support count I need to check. How many item sets are satisfying? You can see here 1, 2. This is not satisfying, and this is not satisfying. This is not satisfying. This is also. So I have to remove, and I have to write the remaining. That is, we call it as L2. After finding L2, you need to find what next? C3. So what is C3? C3 means which is 3 frequent item set. So 3 frequent means from this one I need to find 3 frequent, 3 joins. Like in each line I need to get only 3 items, not 4, not 2. Okay. So if I make joins of these two, I1 I2, I1 I3, can I combinedly say I1 I2 I3 if I join these two first two part? So this is a one join. I1 I2, I1 I5, can I write it as I1 I2 I5? I1 I2, I2 I3, so can I write it as I1 I2 I3? Already written. I1 I2, I2 I4, can I write it as I1 I2 I4? So like this we need to write I1 I2, I2 I5 if I consider. So I1 I2 I5, already I have written this. So coming to this I1 I3, I1 I5, I1 I3 I5. So I1 I3 I5. Next I1 I3, I2 I3. So can I write it as I1 I3, I2 I3 means I1 I2 I3, no? See, every time if I take 4, no, one should be common, then only I'll get 3 joins. So next I1 I3, I2 I4. Now there is no common item, that's why I'm getting I1 I3, I2 I4, 4 frequent item set. We are not finding here 4 frequent, we require only 3 frequent, that's why we will ignore that part. So next I1 I3, I2 I5, that is I1 I2 I3 I5, again 4 frequent, so we will not consider that one also. So I1, I5, I2, I3. Like this, if I consider, what happens? I1, I2, I3, I5. I cannot consider. I1, I5, I2, I4. So I1, I2, I4, I5. So I cannot consider. I1, I5, I2, I5. So I1, I2, I5. I have to consider. I2, I3, I2, I4. I2, I3, I4. So that is a new one I am getting here. Next, I2, I3, I2, I5. I2, I3, I5. I'll get I2, I3, I5. So like this we need to consider. I2, I4, I2, I5. So I2, I4, I5. So like this, all three frequent set I need to get. This we call it as C3. Now what is the next step? Again for C2 we are getting scanning the database for support count. No? Again find for support count of each one. That means the transactions, how many transactions we are getting? I2 and I1 and I3. All these three we need to get. So what is that support count? And for I1, I2, I5. Like this we need to find for all those things. If I find, I'll get all those things, but I1, I2, I3 I'll get only 2. I1, I2, I5 I'll get 2. For the remaining, if you find, you can find, you will get here the things which are less than 2. So that's why here directly those things are removed. Those are not frequent item sets. So that's why finally I am writing only 2. You can find for I1, I2, I4. Let us suppose if I check for I1, I2, I4 combination, I1, I2, I4, 1, only 1. So which is less than 2. You can consider I1, I3, I5. I1, I3, I5. I1, I3, I1, I3, I5. Only one transaction. So like this we will get for the remaining item sets which are less than 2. That's why we are not taking, because for L3 those things will be compared with support count which are not satisfying with the minimum support count. That's why we are neglecting those things. So like this we need to find L3. Now after L3 you need to get C4. So what is this C4? If want to get C4 means 4 frequent items. What are those 4 frequent item sets from L3? So if only I have 2 sets, so if I combine these two I'll get I1, I2, I3, I1, I2, I5. So if I combine I'll get only one thing, that is I1, I2, I3, I5. So only one thing I'll get. So if I go for the, what is that support count? What is the support count of I1, I2, I3, I5? 4 you need to get. So if I consider I1, I2, I3, I5, so only 1 is there. So support count is 1. So this is C4. Now L4 will be empty. Why? Because it is only one transaction that is not satisfying. So until you will get empty set, you need to find all those things. If you don't get empty here, you need to find C5, next L5, like that you need to get. Now after getting empty set, what is our solution? If you get L suffix k as empty set, now your solution will be L suffix k minus 1. So L4 is empty, that's why L3 is our solution. So what is that solution? 2 item sets are frequent we are saying. So why we are doing all those things means finding frequent item sets. So what are our frequent item sets? One is I1, I2, I3 is one frequent item set. I1, I2, I5 is another frequent item set. That means those customers who are purchasing items I1, I2, I3 combinedly are more frequent. I1, I2, I5 is also one more frequent item set. Like this we need to find. Now if you go to the theory part, a priori employs an iterative approach known as level-wise sets. Why we are saying it as level-wise sets means where k item sets are used to explore k plus 1. That's what. So in order to get L2 I am going for L1. I am checking for L1. In order to get L3 I am checking for L2. Like this you are getting. So that's why where k item sets are used to explore k plus 1. So a priori property, all non-empty subsets of a frequent item sets must also be frequent. So what is the meaning of this one? All non-empty subsets of a frequent. What is a frequent item set we are getting here? I1, I2, I3 is a one frequent item set. One more is I1, I2, I5. So if I say I1, I2, I3 is a frequent item set, there must be all non-empty subsets. What are the non-empty subsets? I1, I2, I1, I3, I2, I3, and also I1 separately, I2 separately, I3 separately. So all these must be frequent. If you see this constraint, if I say I1, I2, I3 is the frequent item sets, so all subsequent, one is I1, I2, is it frequent? Yes, if you can see here I1, I2 support count satisfying. I1 I3, what is the support count? 4, satisfying. I2 I3, what is the support count? 4, satisfying. I1 separately, what is the support count? 6, satisfying. I2 separately, 7, satisfying. I3 separately, satisfying. I1 I2 I3 combinedly, satisfying. So all non-empty subsets must satisfy the minimum support constraint. That is why this property is called as a priori property, and that we are following and we are getting the answer. So join step and prune step. Join step means L suffix, whatever we have taken, that is a join step. That means to find L suffix k, set of candidates k item set generated by L suffix k minus 1. To get L3, L1 joined, L1 sets are joined. To get L4, L3 sets are joined, like that. The sets of candidates denoted by whatever the result we are getting, we are represented by C suffix. The prune step means how you are pruning C suffix k is a superset of L suffix k. So all the superset means all the subsets we are writing here, that is its members may or may not be frequent, but all the frequent k item sets are also included in, we have included everything, you can check it. To reduce the size of C suffix k, how we have reduced? We have checked for a priori property. So this is about a priori algorithm. Now after getting frequent item sets, we'll go for generating strong association rules from frequent item sets. So how to do this one? So those which are strong association rules, those rules must satisfy both minimum support and minimum confidence. Anyway, that minimum support we have done in the previous one, that is with a priori algorithm, we have checked for every item sets with minimum support count. Now the constraint with minimum confidence will come here, so we'll see that one. So how to do this one? It's a process. Association rules can be generated as follows. The first step, anyway, we'll do here, and here you require how to find the confidence also. This is the formula for confidence. A implies B is the one rule. For that, support count of A union B by support count of A. We'll see this one. Now how to generate? So here we received two item sets, frequent item, that is I1 I2 I3, and the other one is I1 I2 I5. So we'll take any one of these and we will go for generating strong association rules. So I'll take I1 I2 I5. For each frequent item set, so I have taken L, which is frequent item set, that is L, generate all non-empty subsets of L. So what are the non-empty subsets of I1 I2 I5? If this is a one set, what are the non-empty subsets? So all subsets I am writing here. So empty set we are not supposed to take. After that, I1 is a one subset, I2 is another, I5 is another, then I'll go for I1 and I2, then I'll go for I1 and I5, then I'll go for I2 and I5, then I'll take I1 and I2 and I5. So all these are non-empty subsets of I1, I2, I5 I've taken. So after that, for every non-empty subset of S, so each one I call it as S. So each subset I'll represent with S of L. Output the rule. What he is saying is we need to write a rule that is S implies L minus S. So I1, if I1 is S, what is L minus S? L means all these things. So L minus I1, so remaining 2 will come here. So I1 implies I2 and I5. Here I2 implies I1 and I5. I5 implies I2 and I5. Here I1 and I2. See, S is I1 and I2. What about L, I1, I2, I5? If I make minus on the right hand side, I'll get only I5. So here I1, I5, that's why I'll get only I2. Here I2, I5, I'll get only I1. So here all those things are there. L minus S, both are same. So I'll get pi here. So if I observe those rules, left hand side, right hand side is there for every rule except this one. Right hand side there is no. So that's why we'll neglect this one and we'll take these 6 rules only first. So we generated rules first. Among these, which are strong association rules, how to find it? So for that we have a constraint where which one you call it as, if support count of L by support count of S is greater than or, of course this is, we call it as confidence. The formula for confidence is greater than or equals to minimum confidence. So first of all we'll find confidence value for each one. So confidence value for the first rule. So there's a rule 1, 2, 3, 4, 5, 6. So confidence is equals to support count of L by support count of S. What is L? I1, I2, I5. So what is the support count of I1, I2, I5? If you see in our previous one in frequent item sets, you can observe what is the support count of I1, I2 and I5. So if you observe here I1, I2, I5, the count is 2. Like this we need to consider. Support count of L, that is 2 by support count of S. S means left hand side, that is I1. So what is the support count of I1? So the support count of I1 is 6 here. Like this we need to consider. So 2 by 6, which is approximately 33.3%. Next, if you go with the next one, confidence, that is support count of L by S. L means of course 2 only, by support count of, what is S value? Left hand side, that is I2. What is the support count of I2? 7. You can observe there, you can see in that. So this is approximately 30%. I am taking approximately. Confidence is equals to next support count of L. L means 2 by, what is on the left hand side? I5. What is the support count of I5? So that is 2 only, so which is 100%. Next, confidence is equals to here support count of L means 2 by, what is on the left hand side? I1 and I2. We need to check for support count of I1 and I2. So I1 and I2, the support count is 4. So which is 1 by 2, which is 50%. Next, confidence is equals, so 2 by, so what is there on the left hand side? We need to check I1 and I5. What is the support count of I1 and I5? So that is 2 only, 100%. And the last one, support count of L means 2 by I2 and I5, 2. So which is 100%. Now we received all these confidence values. Now you can check out what are the strong association rules which this confidence is greater than or equals to minimum confidence value. Let us suppose if the minimum confidence value it is given as 60%. I am taking minimum confidence value as 60%. So which rules are satisfying this 60%? 1, 2, 3. So the rules 3, 5, 6. The rules 3, 5, 6 are strong association rules. Like this we can find which are strong association rules and weak association rules. So this is about generating strong association rules here by using association rule mining. Thank you.